Good morning, grade 7. As promised, we need to move now to the second module of the third quarter. This is weeks 5 to 8. Again, this is 4 weeks, right? With limited activities. This is concentrated activities, right? So, this module entitled Waves, Light, and Sound. How we are affected with these waves, light, and sound. What are the effects? What else? What are the practical uses? So those are just bits of information or data that we'll be discussing in this module. Waves, okay? Waves always begin with a source of energy. Waves are energy, of course. Source of energy that causes a back and forth or up and down disturbances or disturbance or movement, okay? A wave is a disturbance that transfers energy from one place to another without transferring matter. Okay? Energy transfer. By the way, talking about your previous activities, again, I am still in the middle of recording them. Okay? Those who will be submitting them late for this third quarter will not be recorded. I'm sorry. Okay? I will give a deadline until this third quarter to submit your second quarter activities, or else I will not record them. Please inform them. Okay? There are a lot of your classmates, there are a lot of you who didn't actually submit some of the activities. And of course, yes, the exam, RJ. What happened to the exam? You took the exam. Okay, wait, let me stop the sharing first. RJ, you took the exam offline or online?
Offline.
For the second quarter?
Yep.
Okay, let me check. This is the problem because I will record those, I'll record the grades or scores you had just submitted. Okay? If you didn't actually submit or did your activity or do your activity, then I cannot record anything. Of course. Let me check. Evaluate. Yeah. I already got your second theoretical test. RJ,
Okay.
it is already recorded. Any other concerns?
No. No.
All right, let's continue. Energy transfer. When you lift a pebble, okay, you transfer energy to it. Okay, you're supposed to drop the pebble into a pond. The pebble's energy transfers to the water. Lifting the pebble. Okay, you lift something from at rest. This is actually in the laws of motion by Newton. Okay, my internet is so slow. Okay, it's okay. Okay, when you lift something from a body at rest, okay, body at rest meaning it doesn't move, okay, it just stay there. That is a body at rest. When you lift something, you transfer energy to it. Okay, you're transferring energy. Okay. Now, when you drop, okay, when you drop something, okay, you transfer or the item that you actually drop transfers energy to the next item. Okay, this is what happened when you pick up a pebble or a rock. You're actually lifting it, you're transferring energy to it. And when you drop, this pebble transfers the energy to the water or the other substance or other matter to it. Okay. Waves carry the energy away from the point where the pebble hit the water. Okay, the water itself moves up and down. Why? Because there is a concrete transfer of energy from the pebble to the water. Okay, the water itself moves up and down as wave passes. Okay, But water does not move along with the wave. Does not move along. Meaning to say that the matter, okay, solid, liquid, gas, and matter is still in its place, okay, but only the wave pass through, right? Two main types of waves. Okay, let's classify first, what are these waves? Some waves carry energy only on matter or to matter. Other types of waves can carry energy to matter and empty space or vacuum. Okay? Mechanical waves. A wave that travels only to matter is a mechanical wave. It needs a medium. Okay? A medium is the matter through which mechanical wave travels. Medium, media, plural, medium, singular. And mechanical wave forms when the source of energy causes particles that make up the medium to vibrate. This vibration actually what? This vibration creates movement, but not with the matter, okay? It only travels through the matter. For example, a pebble falling in the water transfers its kinetic energy to the particles of water. Okay? It has energy because you actually pick it up. You transfer energy from this pebble. Okay, you transfer energy to the pebble, and the pebble transfers energy when you drop it in the water. Okay, and again, the water particles move. Okay, just like this one. Okay, dropping a pebble will create a what? An up and down motion in the water. But the water there stays there. Only the waves that actually travels in the matter. Remember that your water is a water state or a liquid state. It's a state of matter. Okay. Electromagnetic waves. If we have mechanical waves, we have also electromagnetic waves. A wave that can travel to empty space or to a matter is an electromagnetic wave. It can actually travel to a matter. It can also travel to empty space or a vacuum. Okay? Or without medium. Simple. Mechanical wave needs medium, and electromagnetic waves, it doesn't necessarily need a medium for it to travel. Okay? This type of wave forms when when charged particles such as electron vibrates. For example, electromagnetic wave transfers the sun's energy to Earth through empty space. It travels, right? Your ultraviolet rays, UV rays. It travels from the sun, which is the source of energy, going to the Earth. How? How it actually travels? It travels to empty space. It doesn't need any medium to travel. So it can actually transfer. Once the wave reach Earth's surface, they travel through matter, okay, such as atmosphere or a glass window of your house. It can pass through because this is electromagnetic wave. It doesn't need a matter, it doesn't need anything or a medium to travel, but it can also pass through a medium. It can also pass through a particular matter. All right? Just like this one. There are a lot of electromagnetic waves. We call them or we pin them as EM waves. We have radio waves, microwaves, infrared, okay, visible light, UV, your ultraviolet rays, your X-rays. This is common because you can actually hear this in hospitals or at home discussing about something. And of course, the gamma rays or gamma radiation. Describing wave motion. How can you describe wave motion? Okay, hold on. I'll just take this. How can we describe wave motion? Some waves will move particles of medium up and down or side to side. up and down or side to side, perpendicular to the direction of wave travels. Now let's take a look at this one. Transverse waves. What is the movement of transverse wave? Let's take a look at. A wave in which the disturbance is perpendicular to the direction of the wave is a transverse wave. So how can we consider a wave transverse? And electromagnetic waves are transverse waves. Okay, the electric and magnetic disturbance moves or are perpendicular to the motion of the vibrating charge, perpendicular up and down, perpendicular, okay, to the movement or the direction of these electromagnetic waves. Okay, just like this one, this is a transverse wave. Why, sir? Because the movement here is up and down. As you can see, okay, just like when you disturb a pond of water, what else? Okay, when you have your frequencies, these are transverse waves. Okay, this is up and down, right? We have parts of the wave here, okay, the crests, the upper, okay, the throw, the lower, the amplitude, the distance between crest, okay, the distance half of the throw and crests, okay, that's the amplitude, or half, okay, in the central line going to the crest, and in the central line going to the throw, this is the amplitude, this one. Okay, the distance between the central axis going to the crests and the distance between the central axis going to the throw is considered as amplitude. The distance between crest to crests, this one, crest to crest is wavelength, throw to throw is wavelength. Okay, longitudinal waves. Longitudinal from the term or root word longitude. Okay, a wave that makes particles of a medium move back and forth. If it is back and forth, okay, to the direction of the wave travels is a longitudinal wave. Back and forth. Longitudinal waves are mechanical waves. Since this is considered as mechanical waves, it needs a medium to travel, right? Like the transverse wave, longitudinal wave disturbances passes through energy from particle to particle of a medium, okay? Just like this one. The movement here is back and forth, okay? Your spring is a longitudinal wave. Have you seen a magic spring before? Have you played magic spring?
The long
No.
ones?
Yeah, the colored one, the rainbow colored magic springs.
No, but I've seen
No.
one.
Have you seen those? When you move the magic
Yes.
spring, okay, when you move them from left to right, okay, you're actually transferring energy from left to right. And the transfer there is actually what? Back and forth. They're actually moving back and forth. Okay, that's one good example. What else? Springs, ordinary springs. When you stretch a spring, okay, and release over, it will transfer its energy to the center. The energy there that you actually exerted will be transferred to the spring, and the spring will move back and forth. That is longitudinal wave. Okay, just like this one. Okay, if the movement again is back and forth, it is considered as longitudinal wave. But if the movement there is up and down perpendicular to the movement of the wave, it is actually transverse wave. Yes, longitudinal. Waves in nature. Okay, let's take a look at what are the common waves in nature. Okay, the one observable in nature. Waves are common in nature because many different energy sources produce waves. Two common waves in nature are water waves and seismic waves. Okay, again, water waves and seismic waves. Okay, the one that actually in earthquake seismic waves. Water waves. Although water waves look like transverse waves, they look like transverse waves. As a matter of fact, they are. Water particles move in circles. There is a mixture of transverse waves and movement, okay? A movement of longitudinal waves. Water waves are combination of transverse and longitudinal waves because, again, they're moving in circles, okay? Water particles move forward and backward. That's the characteristic of, if it is moving forward and backward, it is longitudinal
Longitudinal.
wave. Yes. They also move up and down. It is transverse characteristic. The result is circular path that gets smaller as the wave approaches the land. Okay, that's water wave. It's a mixture. It's a combination of transverse and longitudinal wave. Okay, water waves form because there is a friction between wind at the sea and the seawater or the water itself. Energy from the wind transfers to the water as the water moves toward the land. Like all waves, water waves only transport energy. It doesn't actually move the entire water on the other area. Okay, because the waves move to the water waves are mechanical waves. They're mechanical waves. They need what? Water to pass through. Without water, there is no water wave, of course. Okay, there you go. As you can see, there is a circular pattern for motion because, again, water wave moves back and forth. That's the characteristic of longitudinal wave. And of course, up and down, that's the characteristic of what? Characteristic of, if it is up and down, huh? Transverse.
Transfer.
Okay. Again, this is now the mixture or combination of transverse waves and longitudinal waves. Okay. As you can see here, it is clear how these waves or water waves created. This is because of the friction in the air, which transfers in water and the movement of the water itself. Okay. Seismic waves. Seismic waves, this is common. We usually hear seismic waves talking about earthquake. Okay. When layers of rock or Earth's rock, okay, crust suddenly shifts, if there are some sudden shifting of Earth's crust, an earthquake occurs. The movement of rock sends out waves that travel on Earth's surface. An earthquake wave is called seismic or seismic wave. Okay, seismic waves are mechanical waves, of course, because they move to matter. It cannot actually move to empty space or vacuum. It needs a what? A medium to travel. Okay. There are three types or seismic waves. Okay. Did we discuss about this in earthquake? Have we gone earthquake? Okay. Yeah, because these topics are in the higher years. Okay. There are three types of seismic waves. We have P wave or primary wave, S wave or secondary wave, and surface wave. Okay. A mixture of P wave and S wave. Properties of wave. Okay. When scientists describe waves, they describe the properties of wavelength and frequency. There is a frequency. Okay. Wavelength. The distance between the point of one wave, such as crests, and the same point, the next wave, is called the wavelength. The one that I had discussed a while ago, from crest to crests and from throw to throw, is called wavelength. The different types of wave can have wavelengths that range from thousands of kilometers to less than the size of an atom. Okay, frequency. The number of wavelengths, okay, take note, the number of wavelengths that pass a point each second, okay, in every second, how many wavelengths can it pass through in every second is called, it is actually called waves frequency. each second, per second. Okay. Frequency is measured in hertz. Okay. The longer wavelength or the longer the wavelength, the longer the frequency, of course. As distance between crests gets shorter, the number of wavelength waves passing a point each second increases because it becomes what? Shorter. Okay. The shorter it is, okay, the more energy it has. Okay. Wave speed. A wave speed depends on the medium, okay, or type of material through which it travels. Electromagnetic waves always travel to empty space at the speed of, this is constant, 3 by 100 meters per second, 108 meters per second. That is 300 million meters each second. Okay, this is 300 million each second. They travel through a medium or a mat because they must interact with particles. Okay, again, this is constant. Even the speed of light, it has constant speed also. And again, it doesn't need any medium to travel, but it will become slower. They travel slower through a medium because there is something that they interact with. Okay, there is something that actually restrict their movements. Okay, if you're going to recall the lessons about Einstein's, I don't know, about Newton's law of motions. Are you still familiar with Newton's law of motion?
No.
Three laws of motion by Newton. First law is the law of inertia, which states that an object at rest remains at rest. An object in motion remains in motion unless acted by the unbalanced force. Okay. So if this is the case, if this wave is traveling without a medium, okay, again, an object at rest remains at rest, an object in motion remains in motion, okay, unless acted by the unbalanced force. If there is nobody or there is nothing that actually restricts its movement, it will continue to move unless there is something that what? Interact to it, making it slower in movement. And that's under the laws of motion by Newton, which is actually came from Einstein's idea. Okay, let's move forward. Mechanical waves also travel slower to matter because the waves transfer energy from one particle to another. One particle to another. It transfers energy from some of the particles of this matter to the next particle. Okay, and it takes time. For example, sound waves travel about 1 millionth the speed of light. Okay, but again, light travels faster than the speed of sound. Okay, the speed of water waves depends on the strength of wind that produces them. Okay, the stronger the wind, the faster the speed of water waves. Of course. Amplitude and energy. What's the amplitude and how it actually generates energy? A wave's amplitude is the maximum distance of a wave varies from the rest position or its rest position. For mechanical waves, amplitude is the maximum distance of particles from the medium move from the rest position a wave passes. Okay, the more energy a mechanical wave has, the larger its amplitude. So let's take a look at later the diagram. Here, this is the amplitude, the one that I am discussing a while ago. Okay, the distance between the central axis, this is the central axis, going to the crest, or the distance from the central axis going to the throat. That is your amplitude. Okay, so again, the bigger, okay, the wave, the bigger also the amplitude. Wave interaction with matter. Are you still with me?
Yes. Yeah.
Yes.
All right. Wave interaction with matter. Do you have any questions so far with the discussed topic?
No.
No.
How about RJ, Jairus, Levi?
No.
All right.
It's
When
kind of
you
hard
knock,
to remember everything.
you still remember everything?
No, it's hard to remember everything.
And that is why you need to ask question. And of course, these are recorded. Okay? You can always check on it. Okay? I always make it in my mind to upload this after in order for you to review. Okay? And of course, my PowerPoint presentation is in the LMS. You can always download it. Okay? That's how generous we, the teachers at Southbrook. We usually give all our outputs, all our PowerPoint presentations in you or to you, to the LMS. Okay? That's why we have LMS. Right? Again, however, when the person in the next room hears the knock, when you knock on the door, okay, longitudinal sound waves transfer the energy of the knock through the door. Okay, when you knock, it transfers energy to the door. However, when a person in the next room hears the knock, it is not as loud as the sound on the other side of the door. It is not that loud. Why? Okay. The sound is weaker after it passes through a door because the waves interact with the matter that makes up the door. And of course, again, if this travels to a matter, it becomes lesser and lesser. The energy there becomes lesser and lesser. Hold on, I'll just take this call. Okay, let's continue. Are you still with me?
Yeah.
Hey, Jaden. Knock, knock, knocking on heaven's door. Good luck. Okay, let's continue. Again, when you knock a door, okay, of course, you hear it louder outside because, again, this is the source. This is where the source of the knock or the sound came from. But when it travels to a matter, it becomes weaker and weaker because it interacts with another matter. It react with the wood or it react with the matter that composes your door. Simple concept. Okay. Don't make it hard. It's really easy. Transmission. How do this transfer? Some of the sound from the knock passes through the door. Okay. It successfully passed through the door. The wave transmit or carry the energy, okay, all the way to the door. Okay, the energy then passes into the air particles, and the person on the other side hears the knock. But again, it needs to interact with another matter. Again, this wave needs a medium to pass through. Sound waves needs medium to pass through. Okay, this is the reason why if you're going to expose yourself in a vacuum, okay, you cannot hear anything. Okay, just like, sure, what do you mean by vacuum? What's a medium? A medium is anything that actually uses by the wave to travel. That's a medium.
Oh,
Okay, when you expose yourself again in a vacuum or an area without a medium, no air, okay, no wind, you cannot actually hear a sound, or these waves cannot travel because these are mechanical waves. You can actually observe this one in a thermos. A thermos is a vacuum. Sure. Are you sure? Yes. Then definitely sure. It's a vacuum. Okay. That's how your thermos retains heat, because it is a vacuum. So you try putting your ear, okay, in an empty thermos without anything there, without water. You put your air in a thermos and you observe what can you hear in a thermos, because that is a vacuum. Right? Let's continue the lesson. I didn't hear my internet. Let's continue the lesson by next meeting, simply because we're running out of time. We still have 7 minutes, but I need more time for the discussion, right? That's how serious our discussions are, okay? Lagi, your thermos is a vacuum. You try, okay? That's one property of a thermos. They are vacuum, okay? Since they are vacuum, you can observe on them how these sound waves travel in a vacuum, if they can actually travel. And you seal it in your ear, okay? You observe what's with the vacuum, right? Empty thermos. You try it at home, right? Do you have any questions so far?
No.
Question
No.
before we Okay, again, reminding everybody to check on your activities. Okay? Again, you cannot blame me with your grades if in case, because I already given you a lot of chances, a lot of reminders, right? Let's continue by next meeting, grade 7. Have a nice day, everyone. Take care. Bye-bye.
Bye.